Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. How are you? I hope you would be fine and enjoying yourself. So, let us start with our chapter number 5, General Science. So, come to the page 62. This is a new chapter, and we are starting this chapter with the first topic, which is the chemical reactions. Before starting this topic, I would like to recall your 7th class general science, where we had studied the physical change, chemical change. If you remember, I was there and I was teaching to you the same class, and we learned over there that there are two types of changes. The one type of change which can be reversed. For example, if you freeze the water, what happens? Ice is produced. But if you allow the ice to place in a normal or warm place, it will again melt to form water. So the conversion of water into ice, and from back ice into water, both can be interconverted. Okay, it's a two-way traffic. Both can be reversed. So this was some sort of example of physical change. But here, the other type of change, what we call chemical change. Chemical change is a change which can never be reversed, or can never be reversed under ordinary conditions. They require some special conditions, some special circumstances, and some special equipments through what we can reverse it. Otherwise, it's totally impossible to be carried out. So I will really focus over this chemical change. So now give me some examples from the chemical change. Let's say a bomb blast takes place. This is some sort of chemical change. Similarly, if you have a piece of paper and you lit it fire, if you burn the piece of a paper, what happens? Paper contain carbon, hydrogen. What happens actually during the burning? During the burning, something combines with oxygen to produce carbon dioxide and water vapors. Both carbon dioxide and water vapor evaporates, leaving behind ash. Ash, I mean in Urdu it is rock. So ash is left. Can we convert back ash into paper? Can we make paper again from the ash? Never, never. Nobody can do it. So it's absolutely impossible to reverse that change. So such sort of changes, they are called what? Chemical changes, and chemical changes are represented by the chemical reactions. So what are the chemical reactions? Chemical reactions are the representation of the chemical changes. And so what are the characteristics of such changes, such reactions? So the change which is permanent and irreversible, which is forever and cannot be reversed. Okay, so similarly, new substances are produced. Composition changes. So what happens during the chemical reaction? First of all, some new substances are produced. For example, if I combine carbon with oxygen, carbon dioxide is produced. Okay, these two which are combining together, which are reacting together, these are known as reactants, and the new substance which is carbon dioxide produced, this is called products. Okay, so reactants combines, they disappears, and what appears? Actually the carbon dioxide, that is the products. So these, the left hand side substances which react, they are called reactants, and the new substance which is produced is called product. Here a single product is produced, but there may be some more products. Okay, so chemical, this is some, you can say, a typical example of a chemical change. You see C, so this is an atom of carbon and the two atoms of oxygen, okay, and they combines together to form a molecule. Molecule is a group of atoms connected together. Let me show a model of a molecule I have prepared for some other class, but I will just show you for your clarity. Look at this. Let me invert it. Students, look at this. This is some example of a molecule. Look at it here. These are the different atoms which are connected. You see, this is a three-dimensional picture. And the force which binds these atoms together is called bond. Okay? So this is a molecule, and in which these different types of atoms are connected together. So actually what happens during a chemical reaction? During the chemical reaction, the substances, the molecules reshuffle. Okay, so let us discuss here. For example, here it was just a single atom carbon and two bonded oxygen atoms. So the bond between these two breaks. One oxygen goes to the one side of the carbon and other oxygen goes to the other side of the carbon atom. So in this way we get COO, we call it what? CO2. Actually the name of this new substance is carbon dioxide. Okay, carbon means C represents carbon. There are two oxygen. So in Greek or Latin language, the numbers are mono for 1, di for 2, tri for 3, tetra for 4, penta, hexa, hepta, octa, nona, deca, undeca, dudeca, then numberless. Okay, so here one carbon and two oxygen, we represent it how? One carbon and two oxygen is carbon dioxide. Di means two oxygen. So one carbon and two oxygen, CO2. So this becomes the formula of carbon dioxide. So the chemical reaction, which for simplicity is shown above this atomic diagram. So carbon C for carbon, O2, the two bonded oxygen atoms, O2, and then CO2 for carbon dioxide. So this is carbon dioxide, O2 is oxygen, and C for carbon. So this was an example of a chemical reaction. And so let us move towards the third point. The chemical change may be accompanied by the evolution of heat, light, or a gas. Sometimes, let's say if you burn a paper, if you burn a wood, if you burn a fuel like CNG, like petrol, like diesel, whatever it is, but in any combustion process, in any burning process, you will see some heat is produced. Yes, fire is produced. The flame is hot. Similarly, light is produced, and sometimes gas, a single gas or more than one type of gases are evolved. So this is the characteristic of a chemical change. So let me summarize this discussion that the chemical change will be permanent or irreversible. It cannot be reversed. Similarly, new substances are produced. And the third is composition changes. What mean by composition changes? For example, O2 had the formula O2. Okay. Now, when it reacts with the carbon and produces the CO2, that is the carbon dioxide, the individual properties of the oxygen are totally lost. It loses its original properties. Okay. So their properties are they entirely or absolutely vanishes, and the new properties of carbon dioxide are now introduced. Okay, so the combining atoms, for example, carbon in a form of wood, in form of natural gas, in form of petrol, in form of diesel, in form of coal, it can catch fire. Yes, so carbon is combustible. It can catch fire. It can burn. And what the oxygen does, it helps in burning. So one is burning by itself and other is helping in burning. So both these two processes, I may say they assist the process of combustion or burning. But when these two combines chemically and produce a new substance, which is the carbon dioxide, it has entirely different properties. You see, here carbon was burning by itself, oxygen was helping in burning process, but when they combines together to form carbon dioxide neither help nor it burns by itself. ये ना खुद जलता है और ना ही जलने में मदद देती है ये गैस. Okay, so now you know the carbon dioxide is used to put out fire. The fire extinguishers, which are the red colored devices usually attached to the walls of schools, hospitals, similarly shopping plazas and many other sensitive places where public rush is too much. So over there these fire extinguishers are there, and what they use a tool to put out fire. That's the main tool to put out fire is the carbon dioxide gas. The same gas is there in those equipments which are over there to extinguish fire, to put out fire. Okay, so so look at here now the properties. One was burning by itself and other was helping in combustion process. But when they combined and they formed carbon dioxide has entirely different property. It is used to put out fire. It's neither burned by itself nor it helps in burning, but it has totally different property. So this means from here I can conclude that during the combustion the individual properties of the atoms or molecules are lost, and the properties are only by virtue of the new substance which is being produced. Okay, so now let me proceed toward another example. I will discuss these three examples of the chemical reactions almost given in your book, but I have also mentioned here for your clarity. Similarly, now this is methane. This molecule is called what? Methane. Carbon in the center, at the right, left, top, bottom. 4 hydrogen atoms are connected. So connect one ball with the 4 balls. One ball is comparatively larger. This represents the carbon, and the side atoms which are attached, they represents hydrogen atoms. So this whole arrangement, this whole molecule is called methane. Where is methane in our ordinary life? The sui gas, the natural gas which we use for cooking, for heating rooms during winter, all they have 90% of this gas. Okay, so sui gas, or whatever called in Pakistan and other part of the world, they call it natural gas. So natural gas and sui gas both are same. Actually, the natural gas was extracted initially in 1951 from a place in Balochistan which was known as sui. So that's why in Pakistan it's locally called as sui gas, but actually it is natural gas. Okay. Now it's going to react with the oxygen. Oxygen has formula O2. O2 is nothing but 2 oxygen atoms bonded together. Now these two will react. These bonds which hold these atoms together, they will broken down. Similarly, this bond will also broken down, and they will break down, and these atoms will recombine or reshuffle in a new way to produce the new substances. So here oxygen is one of the reactant, methane is another reactant, but when these two combines during the burning process, when we combine, for example, this reaction is taking place in the stoves, whatever we use in our homes. For example, your mama is cooking meal or something else. Actually, she is carrying out this reaction. Methane, when it burns, it combines with oxygen. It produces 2 types of substances. In the first reaction, it was only just one product. Here we have 2 types of product. The first is same as it was carbon dioxide. Carbon dioxide is produced, but along with carbon dioxide, here we have water vapors also. The 2 molecules of water vapors, H2O, are attached here. You see here the O represents oxygen and the HH represents 2 hydrogen atoms. So 1 oxygen and 2 hydrogen atoms, they constitute the formula of water. Okay, so this is another water molecule. So this means there are 2 water molecules are produced, 2 H2O are produced. Similarly, here the 2 oxygen atoms O2 were allowed to react. So these are called what? Reactants, and these are called products. Reactants are the substances which disappear or which react together and Products are the substances which are being produced. Similarly, in the third example, this is the quite familiar example. For example, this reaction takes place when we allow to react, if we mix the oxygen gas with the hydrogen gas and then bring a glowing splinter or flame near to the mixture of these two, a huge explosion will take place and hydrogen will get combined with the oxygen to produce again the water. Here these two are the oxygen atom bonded together. So this is one oxygen atom, other oxygen atom, we call it O2. O2 is the formula, the name is oxygen. And similarly, the two hydrogen atom bonded together are said to be H2. H2 is actually two hydrogen atom bonded together, but here two molecules of H2 are involved. So two molecules of hydrogen combines with the one molecule of oxygen upon combustion, upon burning. So two molecules of hydrogen combine with the one molecule of oxygen O2 to produce two molecules of water. This is the one water molecule and this is the other water molecule. The larger atom represents the oxygen atom and the small atoms, they represents the hydrogen atom bonded together. So dear, let me wind up this task. So I am giving you some a bit of homework. You have to write other three examples of the chemical reaction by your own. Check your book, check other sources. Okay, you can also consult your brother or mother, any one of your relative for this purpose, but you have to explain it as well. Okay, so write three examples of not these which I have discussed. Okay, you have to write three examples of the chemical reaction from your own. Okay, and then write on a white page and then send it to me at my number on WhatsApp. I will check it out. Okay, so stay healthy, and if you have any query, you can call me through WhatsApp, you can call me through phone. Whatever do you have in your mind, whatever confusion do you have in your mind, okay, so clarify it, clear your concept. The clear concept will actually leads you to success. Okay, so keep smiling, dears, my dears, keep smiling, and hope you would have understand this lecture, and all the best. I thank you all.